Hello and welcome to the session. In this video, we'll discuss how we can apply KNN algorithm. This is a problem. Consider a student performance training data set as shown in this table. Here we have three independent variables. This is a serial number, CGPA, assessment, project submitted, and based upon these three independent attributes, the result would be declared as either pass or fail. So CGPA, assessment, project submitted by the student are the independent attributes, and based on these three independent attributes, result would be calculated. So result is a dependent attribute and it is a discrete value because either it can take a value as pass or fail. So this table is given. So let's apply KNN algorithm here on a test instance and find out based upon the test instance whether the student will pass or fail. So before you start the KNN algorithm, first write what is the test instance. So suppose in the question the test instance is given for this as the 6.1, 40, 5. So 6.1 is the CGPA and 40 is the assessment marks, 5 is the project submission marks. So this is a test instance and the categories is given. So based upon you have to find out whether the test instance will pass or fail. So we are going to classify the test instance. Now in this case, let's use Euclidean distance to find out the distance between the test instance and the target and the training database. So let's take k is equal to 3. So as discussed in the previous session, k is basically the nearest neighbors. So we are going to choose 3 nearest neighbors. Step 1 is calculate the Euclidean distance between the test instance and each training instance. So repeat the table which is given as it is. Now add just one more column. The one more column that I am adding is here the Euclidean distance. So the formula for Euclidean distance was discussed in the previous session. Just to repeat, it is square root of the difference of the x coordinates, y coordinates or z coordinates. Since in this case I have 3 coordinates, so let's take them as x, y and z. So how do you calculate the Euclidean distance? Square root of this one 9.2 minus the test instance 6.1 whole square plus 85 minus the test instance value 40 whole square plus 8 minus 5 the whole square. So the value I am getting here is 45.2063. Similarly, repeat this for all the training instances. See, again just repeat. You can observe here, this is the 8 is the first CGPA, 80 is the assessment mark, 7 is the project submitted marks. The rest of the things will remain the same. This is the test instance CGPA, test instance assessment, test instance project submitted. Square each of them separately, add them up and then take the square root. So I have calculated the values for all of them. Let's now try to find for the last one. So let's say it would be square root of, what is the value here? CGPA 8.9 minus 6.1 which is the test CGPA plus 91 minus 40 is the test CGPA plus 9 is the project submitted marks minus 5 was the test project submitted marks. So find out this value. So let's take a calc and work out this. So just take square root, put the brackets, take the first one 8.9 minus 6.1 square plus 91 minus 40 square plus 9 minus 5 square. Close the brackets. So you are getting the value as 51.2331. Let's light up to 4 points. So this is a step 1. So we found the Euclidean distance for all the training instances with respect to the test instance. Now step 2 is Now we have got all the values. You have to sort all the Euclidean distances in the ascending order. So the step 2 is sort the distance in the ascending order. Select the first 3 nearest training data points to the test instance. Why 3? Because the k value is 3. So therefore the selected nearest neighbors are, after ascending, put them in ascending order. So let's take the smallest one. The smallest one is this. So this is the first one. The next smallest one is this. This let's mark it as 2. The next smallest one is this. So the instances are the 4th, the 5th and the 7th. So I am just copying them as it is. The 4th table, I have just copied all the values. The 5th, I have copied all the rows. The 7th complete row I have copied. Just copy the instance number. Euclidean distance is enough. And what was the class? We observe the class for all of them is fail. This is fail, this is fail, as well as this is fail. So we have just copied it as it is. Okay. From the first table which we had in step 1, just copy the instance, that is a serial number, Euclidean distance, and the class. Now step 3, you have to predict the class of the test instance by majority voting. So by majority voting, there is no confusion here at all. All the classes are fair. Therefore, the class of the test instance predicted is fail. So that's it. So this is our final result. So the test instance which was given in the question is predicting that the student is going to fail. Thank you so much. Please subscribe to the channel and please watch the next video for the next topics on weighted KNN. Thank you so much.